So we talked today ML flow. This is the next session, day 40, ML flow. So in this session, we are going to study what understanding of the ML flow theoretically, and first we will integrate our hyperparameter optimization tool Optuna. So code would be little bit changing over here. Code would be little bit changing. So whatever, if you see the with flow start underscore run, that should be the objective of the Optuna. That should be the objective of the Optuna. So we will do that things accordingly. Rest of the code would be as it is. There won't be any change, right? We have set the experiment over here, simple linear regression, and here I can say Optuna. So we need to install the Optuna first. First we need to install what? Optuna. Do you remember the thing we have installed the Optuna? How to install the Optuna? The hyperparameter tuning utility. So npm install Optuna. Optuna. Install it. So Optuna integration, the objective function we need, and we need to create the study, and then we need to optimize it, right? So what happened? Is there any error?
It should be PIP.
Oh, I'm sorry.
It's
Pip install Optuna. So this is what happens if you work as AI engineer as well as a full stack engineer. Okay.
and that would happen.
Yeah.
Especially with the NPM and the PIP.
Yeah, npm and pip, a lot of confusion is there. So ml flow set experiment, this experiment name, and here we need to just add objective depth. This would be the objective. The trials we are going to take. So whole of this code needs to be moved, and we can write a function. Instead of doing this thing in this way, we can write a function def start ml flow. In background, ml flow UI bg in background. So default port would be the 5000. So we would be having this command we need to fire ml flow UI port, this given port. Okay, we just have created a list, and we will create the sub process. I think we need to import the sub process also. We need to import the sub process. So this is the ideal thing that you can do. Indentation problem. Python is an intended language. So scopes are defined using the indentation. Now what? Okay, that should be here. Okay. So we are just creating the sub process. This is a standard Python code to run something in the background. It will assign you one PID and like that. Well, now, so just comment these things over here. I'll keep this code also. And from here, I need to return the MSE, mean squared error, right? Mean squared error. And then Python startup code. If underscore underscore name is exactly equals to underscore underscore main, then we need to do this thing. Study we need to create Optuna study is equals to, we didn't import the Optuna, import Optuna. So here Optuna dot create underscore study. We have talked about this in the last session. Minimize the MSE. Meaning of this is minimize the MSE. That's our objective is. Then study dot optimize, and we need to pass the objective function that we have written. If you see, this is your function, this is your objective function. So we need to pass the objective and number of trials, n underscore trials 10. N underscore trials is nothing but what? 10. Now best trial, print best trial, then trial is equals to study dot best underscore trial, print value is trial dot MSE value, trial dot value, then params for key value in trial dot params dot items, and here we can say print underscore key and the value, and sorry, and after this start ML flow in BG 8989. Okay, let's try to run it. Can you see? Trial 1, trial 2, trial 3, 10 trials would be there, which will minimize the thing. And 8989, refresh it. Simple. Yeah, this is the Optuna one. And here you can see the details. 9.8 R2. So 33 seconds, 47 seconds. These are the 10 trials. 0.65 over here. 0.65. Well, we can change these things also, columns also. So here we can add the MAC as well. Yeah, parameters MAC. It is already there actually. So we can remove the source. You can remove the models, data set for now, but in real you might be needing that. Can you see our MAC for the 10 iterations? But it is fixed, I think. It is almost fixed. So there is no possibility. So 0.65 would be this. Correct. So you have integrated the Optuna. What is Optuna? Hyperparameter tuning utility. Hyperparameter tuning utility. Okay, that's about what you can say this ML flow. Now let's go and just talk about the ML flow in more detail. ML flow overview, right? What is ML flow? Is a solution to many of these issues in this dynamics landscape, offering the tools and simplifying the process to streamline the ML life cycle. Now, ML life cycle, you might have got it, and the collaboration amongst the ML practitioners. Whether you are an individual researcher, a member of a large team, or somewhere between, ML Flow provides the unified platform to navigate the intricate maze of the model development, deployment, and the management. ML Flow aims to enable the innovation in ML solution development by streamlining the cumbersome logging, organization. Now, see, these things are really challenging. Logging, organization, and the lineage concern. So you can just go to the URL, go to your run, and you can see the details of particular thing. So this is very important. So how do you do this thing? Excel sheet otherwise. So manually you will feed these entries into the Excel sheet, right? You will manually enter the details in the Excel sheet. And that is really bad. Yes or no?
Yes.
The only alternative to manage these things in Excel sheet, right? So what you will do, you will use the ML flow in that case. Now, if you see what do you mean by tracking, ML flow tracking provides both API. So here you can integrate this, as you said, Grafana and other thing. You can pull out these details, right? You can pull out these details, and then you can, what you can say, use the API, and by means of API you can get these details, right? So this is the other tab actually. So here you can say, if you see, we can create the models over here, description, tags, and the versions. And here you go and just adding, no models are registered yet. We can register the models also, and those models will stay over here. Those models will stay over. If you go here and if you can say new run using notebook or using prompt engineering, so here you can have the, from here also you can run it actually, right? Because Presently our source is .py file. Okay, so I'm telling you, once you understand this concept of ML flow, you need to explore this tool on your own. There are a lot of settings available, right? And there is no point in covering those settings. So it's just a software you need to understand. What is sorting, columns, and other thing. A pretty much same things we are having, right?
Correct.
But the integration with the Python code and your model details tracking is really important. So here, this code integrates the Optuna. Optuna is a hyperparameter tuning utility. We have separately studied this thing, right? In the same fashion, we are understanding the ML flow. What is the model registry? A systematic approach of the model management. Model registry assists in the handling different versions of the model, discerning their current state and ensuring the smoother productization. It offers the centralized store. So you'll get all the models over here. That is nothing but what they are talking about, model store. Can you see this thing? This is the every model, whatever model you need, you can have that model easily available to you. If you see, this is the pickle file and this is the model description, right? ML flow. So prompt engineering and other things, just forget about it. Recipes, serving a guide for structuring the ML project. So you can go to the recipes, and if you see the local, whatever we have done, all that things are written over here. Whatever we have done, all those things you can see over here, right? On the local machine also you can, run the server separately, instead running it in. So here what we have done exactly in this function, we just have fired the command. We can fire this command anytime in the BG, this code. So this command you have fired with the help of Python. This command you have fired with the help of Python. You can otherwise fire this command on your own. Not a big deal. You can do that as well.
Correct.
Any questions?
No, that's good.
Okay.
So the registry, okay, so we heard somewhere the registry here.
Yeah, just a minute. So that thing is also available here. ML flow model registry. Yeah. What's your question?
No, so just one thing came in my mind because when we work on the microservices, the registry
No,
also have.
that is different. That is altogether different concept. So ML flow model registry is the centralized model store and set of APIs and UIs to collaboratively manage the full life cycle of the ML flow model. In the case of the microservices, registry is the registration of the microservices.
Correct.
Right? So we
Right.
were using, if you are in a Spring, we were using Hystrix and what not. Eureka.
Eureka.
Eureka is also there and Consul is also there.
Yep, eventually.
ML flow model registry component is the centralized model store. So here all the models. So in this case, it is the registry over here. If you see the models, so model related details you will find in here. Okay. So UI workflow you can see over here. Register a model, Can you see SK models, ML model, Conda YML? So this is the thing. Click the register button. Means they are asking you to go here. Can you see register this model? So select a model. So this AB and register it. Now if you go to the models, so one version of the model which you think which is running correctly, right? Which you think this model is working properly and it is having all the details. So that would be listed inside this thing, right? Source run this, all the details and the plot.png artifacts you can see over here. This is what the model registry is. In the model drop downs they have seen, so you can do this thing with the help of APIs also. You can do it from the code also. Can you see that? You
Yep.
can do it from the APIs also, but you can do it in the UI also. So for everything you would be having some piece of code that you need to check. So in the traditional ML native support library, ML flow eval. So we have done all these things, remember that?
Yep.
So whatever code I have written, which covers, can you see hyperparameter tuning with ML flow and the Optuna? We have done this thing. So if you do this thing on your own, it might take many hours, right? So that code I have written
Right.
in front of you. A basic
Yep.
code. You can modify the code as per your requirement. So we have talked
Correct.
separately about the Optuna. What do you mean by Optuna? Okay, so there are many other things. So custom PyFunk models with the ML flow. So then many other things are there, absolutely. But our our focus was on the scikit-learn. This framework we have used internally. And scikit-learn can be well integrated with the ML flow. So this is the only official document. You may want to refer it. This is the only official document you want to refer it. And you can read it over here. So let's go through it. So ML flow's versatility enhances the workflow across the various roles, from the data scientist to the prompt engineers, extending its impact beyond just confines whatever. So why scientists leverage ML flow? Experiment tracking and the hypothesis testing, code structuring for the better reproducibility, model packaging and the dependency management, evaluating the hyperparameter tuning selection boundaries, comparing the results of the model, retaining over the time, reviewing and selecting the optimal models for the deployment. MLOps professionals like the DevOps people, there is a new trend, MLOps, manage the life cycles of the trained model, both pre and post deployment, deploy the model securely to the production environment, audit and review candidate candidate models prior to the deployment, manage the deployment dependencies, data science managers reviewing the outcomes of the experimentation and the model activities, collaborating with the teams to ensure the modeling objectives align with the business goals. Prompt engineers, why prompt engineers too? Evaluating the experimenting with the large language models, crafting the custom prompts and the persisting their candidate creations, deciding the base model. So you will not understand few terms over here. What do you mean by the candidate creations, large language models, right? Base model will, you will, over the period of time you will understand these things. So they have given a lot of details over here. And if you see, these are few things you might need to see. And that's the short, that's all about what you can say the ML flow, right? That's all about the ML flow. If you have any specific questions, go ahead and ask me.
So for the deployment, so if we go on ML Flow, so we have the PKL file, that is the model
Correct.
packaging file.
Correct.
How to, means the question is here, can we directly leverage that model from this flow on the
Yeah.
file?
Yeah. So just a minute. So actually that is the option available in a simple linear regression. Let's take this thing. This is the source. So we can load this model from the ML flow.
Mm-hmm.
Just a minute. I would like to show you that part. Artifacts. So a simple thing, can you see there is the download option? Just download this pickle
Correct.
file and load it. And there is a code also with the, you can just pass this URI, right,
Mm-hmm.
to your Python program, and Python program will load this model from here. That is also
Ah,
one thing. Getting that? So there is something called
yep.
as run ID. Yeah, with the help of this run ID, you can load this model in your Python program.
Mm-hmm.
So we can say saved or load ml mlf ml ml flow loader dot py. So first import ml flow, then here you can say run underscore id. You can get that run id. Just copy this, so where you want to download it, download path. Here I can say dot is the current directory, dot download model underscore URI. So f runs colon forward slash your run id forward slash model ml flow dot artifacts dot download artifact. And here we can say artifact URI is equals to model URI. And where exactly you want to store DST path, destination path, and download path. Here you can pass this download path. Can you see you're downloading? From here you are loading.
So one more question here.
Yeah. Now load the pickle code. Now use pickle code
Yep.
to load it. Yeah. What's the question?
So just the question is like, if we created the model,
Mm-hmm.
correct,
Mm-hmm.
and definitely to leverage that model or to predict some result and some input need to be get it from some other system.
Correct.
So currently, like if we talk about the front end back end, so we have the different system of the front end and the back end, and using some API interface, we are communicating between them.
Uh-huh.
So similarly, from the model to that uh, front end or whatever we are talking, the system which want to leverage the model. So whether means how it will do that using this connections.
Now see, you got this file. So
Correct.
consider that you are writing APIs in a Python,
Okay.
right?
Yep.
Or
Right.
Node.js.
Right.
So you have this downloaded pickle file.
Correct.
Now if you see the Node.js, there is one package, pickle file loader. There is one package, pickle parser, if you see.
Mhm.
So if you know the pickle file, npm install this file. If you know the pickle file, and if you have a pickle parser, right, you can load the package. You can load this particular file,
Yep.
and using this library, using the, so I'm giving you example in the Node.js. Okay. So
Yep.
generally, if you are using a Python over here, if you are using the Python, you need to use something called as Flask. Have you used the Flask?
Not bad.
So this is the web development framework. What is Flask? It's a web development framework. So pickle is the concept of Python and node is something else. So you need to write one microservice in a Python that will communicate with your AI models.
Yep. So that was my question is
Yeah,
you give very good example of the node
correct.
or the Node.js. So that is the means whatever the PKL file is generated that can communicate with
Huh,
any technology. It doesn't have the dependence. Just need to load concept. There.
correct. Even there are some APIs available. Java APIs are also available,
Mhm.
right? But what I recommend you is that if there is one microservice which you wants to communicate with the Python generated models, I recommend you to write the microservice in a Python itself,
Okay.
because the frameworks, because pickle is one of the world class library available in a Python, so that might not be good in a Node.js.
The performance can be
Degraded. So what you can
degraded.
do, you can use a one web service or one REST API in Flask and try to consume the pickle over there.
Yep. Mhm. And using that API, you can
Huh.
communicate from
With the
any
React,
channel.
with the Angular, whatever.
Yes.
That would be the typical flow.
Correct.
So a lot of things are there. But as far as the ML starter, our course is concerned, so this would be the last session of our course. So we have seen a lot of things in a detail, right?
Yep. Right.
So from last 3 months we are working. So we have seen a lot of things in much more details. And MLOps was the last topic, an important aspect.
Yep.
So when you talk about the MLOps, we cover Optuna and the ML flow.
Mhm.
Now you got the exact idea who does what,
Yep.
right? Who does what?
Got
Now we will dedicate tomorrow's topic for your questions and the revision. Tomorrow's two sessions, we will have the quick revision of all the things that we have studied and whatever questions you have enlisted.
Yep, that would be good. Yep.
Fine. So that's it from my end for the today's session. If you have any queries, you may ask. Otherwise, we are good to wind up the session.
I think we can wind up and we'll go through it. We'll have the discussion tomorrow so we can ask this.
Correct. Thank you.
Thanks.